Bismillahirrahmanirrahim. Here is velocity time graph or the speed time graph. As you know that velocity is a vector quantity and speed is a scalar quantity. Because in velocity we discuss direction also, but in speed we don't discuss direction. Okay. As for the graph of speed time graph or the velocity time graph are concerned, they are almost the same. Only few points must be remembered while discussing these graphs. These points are, first of all, the slope or gradient of the velocity time graph gives you the acceleration. Remember this, that the slope or gradient gives you the acceleration. Second point, that positive gradient, mean the line like this, the positive gradient gives you the increasing velocity or increasing speed. And the negative gradient, the line like this, gives you the decreasing velocity or decreasing speed. Now the fourth point is the area under the graph gives you the distance or displacement. Now let us discuss these graphs which I have drawn here for you. Here along the y-axis we are taking speed or velocity, and along x-axis we are taking time taken by the body. Now in the first graph the line is starting from 0 and there is a horizontal line along the x-axis. This line is showing that the body is at rest, initially at rest. The time is elapsing, the time is going on and the body is at rest. Okay, now there is another horizontal line. This horizontal line is showing that the body is moving with a constant speed, which is something here. Here there will be some value of the speed. So whatever the value of the speed is at that point, that will be the constant speed or the constant velocity. As you know that this is also horizontal line. In the case of the horizontal line, the acceleration is 0 because the gradient of the horizontal line is 0. In this case you can see that this is a steeper line and this is positive gradient, and the gradient is positive. It means this is acceleration. The velocity is constantly increasing. There is a constant increase in the velocity. Now here the negative gradient, as I told you that the negative gradient is showing decreasing velocity. Here the negative gradient is shown, and this negative gradient is negative acceleration. As you know that if the velocity or speed is decreasing, then the acceleration will be negative, which is called retardation or deceleration. Now come to this point, that area under the graph. As I told you that the area under the graph gives you the distance or displacement moved. Now in the first case, if I am going to find out area under this graph, so you can see that I have to complete this rectangle. So this shaded region of rectangle will be calculated to find out the distance moved through this point. Okay, so here in the first case you can see there is no area under this graph. The line starting from 0, there is no displacement or distance can be calculated. Now here in this case you will have to complete this triangle. So area of triangle, the formula for area of triangle will be applied to find out the distance or displacement. Now here in this case again you will have to take the area under this line, which is also a triangle. So you can find out the area of the triangle to find out the area under the graph, which is equal to the distance or displacement. First of all, body is increasing speed, then this is constant speed, then again this is decreasing speed, and the body comes to rest at last. Now how to find out the distance covered by the body in these cases? Here I am mentioning for your information that this is positive acceleration, this is A is equal to 0 because the velocity is uniform, and here A is negative because velocity is decreasing. Now how to find out the area under this graph? You can divide this figure into 3 parts, or you can also find out the area under this graph with a single formula, because you can see that this is a trapezium. So if you are finding out the area of trapezium in one go by applying the formula of area of trapezium, half into sum of parallel sides into height, these are the parallel sides and this is the height. So by applying the formula of the area of trapezium, you can find out the distance moved during this time interval starting from 0 till this time, whatever this time is. So otherwise you can divide this shape into three parts. One is the triangle, this is triangle, and this is also triangle, area of triangle plus area of triangle, and the area of this rectangle or square. Depends upon whatever the shape comes here, whether this is rectangle or square. So you can find out the area of these three shapes to find out the distance moved during the total interval. Okay, now I hope this is clear to you. Here I have drawn four cases in which in first two cases the velocity is increasing. Here in these two cases the velocity is decreasing. But here the acceleration is increasing acceleration, and here it is decreasing acceleration. Now here decreasing velocity with increasing acceleration, and decreasing velocity with decreasing acceleration. How we are going to decide that acceleration is increasing or decreasing while the velocity is increasing or decreasing? As I told you that the slope or gradient of the velocity time graph gives you the acceleration. Now let us draw the slope of the graph at a certain points, because these are curves. To find out the slope of a curve, we have to draw the tangent at any point on the curve. For example, I am considering this point P. To find out the acceleration at this point P, I have to draw a tangent line. So this tangent line gives you the acceleration. Now on the curve you can take any other point Q. At Q again I am drawing the tangent of the curve. So these two tangents can tell you that acceleration is decreasing or increasing. Here in the first line you can see that it is lesser steeper and this is more steeper. It means the acceleration is increasing from the beginning and it is increasing acceleration. And the velocity is also increasing because graph is going in upward direction. Now here again the velocity is increasing but acceleration is decreasing. How acceleration is decreasing? Again I am taking one point P. I am drawing a tangent at P. So you can observe that this tangent at P is steeper, but tangent at Q, I am taking another point Q on the same curve. This the tangent at Q is less steeper. So this is showing that the acceleration is decreasing. Okay, so this is increasing acceleration and this is decreasing acceleration. In both the cases the velocity is increasing. Now let us consider this also. Now here you can see that the velocity is decreasing but acceleration is increasing. How it is increasing? Again let us consider a point P here. At P I am drawing a tangent. Now you can observe this tangent. I am taking another point Q. I am again drawing a tangent at point Q. You can see that this tangent at Q is more steeper than tangent at P. It means here the acceleration was lesser but here the acceleration is greater. This shows that this is increasing acceleration but the velocity is decreasing. Now here again, if I am taking a point P, I have to draw a tangent at P and then I can take any other point on the curve like this. I am taking a point Q and I have to draw a tangent at Q also. So here you can observe that here the tangent gradient of the tangent is steeper and here the gradient of the tangent is less steeper, or the gradient of tangent is greater, and here is the gradient of the tangent is lesser. So it is showing that the acceleration is decreasing acceleration. So these are the four major cases of increasing velocity and decreasing acceleration, or increasing acceleration, decreasing velocity of increasing acceleration, or decreasing acceleration.